Welcome back to another series of mock interview. Today we have with us Vignesh Ravisekar. So, hi Vignesh, how are you?
Yeah, I am fine. How about you?
Yeah, I'm doing well. So, Vignesh, can you please introduce yourself?
Yeah, hi everyone. I am Vignesh. I'm from Chennai. I'm a recent graduate from Sri Sai Ram Engineering College. While studying in my sixth semester, I presented a paper on analog domain in IEEE conference, which really intrigued me to take a career on VLSI domain.
Okay.
I was like often fascinated how these chips, small chips, are revolutionizing this entire tech world. And also, I just joined up. I just learned. I am like I have this paper in this paper. I prior to it, I was not like so much interested in taking a career, taking a part of career in this VLSC domain. Later, I just this paper really intrigued me to take a career in VLSI. I joined a training institute, and I just learned about UVM system Verilog, UVM system Verilog, and another digital front-end related skills. And also there, I just implemented the project such as router, and now I'm like going on the verification of UART is going on.
Okay. So, can you please tell us more about the paper that you were talking about that you published in IEEE? So, it uh, motivated you to get into this domain. So
Yeah, yeah,
what
yeah.
was the paper on?
Uh,
Like, just summarize it in brief.
yeah. Actually, it is like a mobile charging, wireless mobile charging related. Back then,
Okay.
while I was studying my sixth semester, there was a COVID. I couldn't implement this into a project. Like it is a
Okay.
kind of we just did a simulation using Protemus software and all. It is kind of like wireless charging, from public places like railway stations or like there we would be installing this piezoelectric sensors. These piezoelectric sensors would be like converting this mechanical energy into this electrical energy. This would be transformed into AC to DC converter, and this would be stored inside this will be stored inside this rechargeable battery. From there, we can charge our mobile phones. Either we can take this source and it will be fed into this IR beam generator.
Mhm.
This IR beam generator will generate a IR signal, which would be like transforming the signal into this phone, which where we would be like installing this IR circuit, which would take and charge automatically.
Okay, so this sounds really amazing. So also you said that you're working on another project that is verification of yacht. So is it
Yeah,
a Verilog based project? So have you completed your design in Verilog?
yeah. It is like kind of already design would be there. Like we would be
Okay.
we need to verify the functionality of the design.
Okay.
This kind of
Okay.
base UVM. I just
Okay.
based
So
on UVM. I'm currently working on it. It's
okay. So
going
you're
on.
currently working on it. So can you tell me what is UART?
Yeah, UART is a basically UART is mainly used for long distance communications, like from one device
Okay.
to another device, and UART is mainly used for this long distance communication, and also it generally works on this wishbone protocol, like wishbone
Okay.
protocol in the sense based upon the baud rates generated by the devices, it will just sample the data from one end
Okay.
to another end. And also it
Mhm.
consists of inside this UR there are like several kinds of registers and control registers, and also controllers,
Mhm.
like for example DLR registers. Based upon each and every registers, like since I am working on the functionality of the design, for a verification point of view, each and every tiny details of the designs, we shouldn't know it. Like we won't be like knowing, we
Mhm.
won't be like accessing this RTL. Instead, we would be based upon the protocol, we would be verifying the design. For example, if the data is transmit, like if we needed to transmit the data,
Mhm.
the control signals would be activated as high for a specific amount of time. Once this again you once the another device obtain that signal, acknowledgement would be sent. Like basically, the handshaking process has been implemented here. And also,
Okay.
I just I tried to write the codes for this monitor and all this TB environment for the UART, and I just
Mhm.
worked on it.
Okay, so for verification purpose, are you like trying to implement a bus function model?
What?
For verification purpose of your design. So, like you said, you're trying to verify the functionality
Yeah,
of
yeah, yeah,
UART, right? So, like we have a TX and we have a RX, right, in a UART.
yeah, yeah, yeah,
So, like, how are you? What is your approach to verifying? You said that you are writing the
yeah,
codes
yeah.
for scoreboard, monitor, etc. But like, are you using a bus function model, BFM, in
Yeah,
your
yeah, yeah,
design?
yeah. Yeah, yeah, yes, yes, yes. Like actually, basically in this specifications, you would be like interface signals, like top model signals would be there.
Okay.
I would be like taking it as signals, like I will be like declaring inside the interface. Okay,
Mhm.
interface. This interface signals, based upon this interface signal, I would be like dividing into clocking blocks, like a
Okay.
driver and monitor, and then there would be like mod puts, which would be like telling the direction. What will be like acting as an input and output for the driver and output for the driver and monitor, and also for the DUV. Then at the DUV, I will be like driving the stimulus inside the driver logic. I will be like driving the stimulus into the DUV.
Okay.
Inside the driver, I would be like using this driver mod put inside it to drive these signals. And also, I will be like writing sequence, like set of sequence. Like for example, like let us say like I'm like considering a sequence of 8 byte.
Okay.
For this sequence, I should follow the specific UART protocol. Like for example, I have to write in this. First, the LCR register should be activated. The
What
7
is
bits should be
LCR?
high. LCR is a line control register.
Okay.
It mainly like UART internally consists of several registers like LCR and DSR register, and also DLR register, and also uh, they are like line status register, interrupt enable registers, and also interrupt high registers. These interrupt registers would be like deciding which kind of interrupt should be available on the UART. Like for example, which interrupt is
Okay.
available. There are like several. For example, inside it there is also a FIFO. Like I am taking a
Okay.
8 byte of data to be transmitted. So like I would be like selecting the I inside the FCR register. I would like configuring into based upon the specific specifications. Like for example, FCR consists of like around 8 bits. Inside it, if these last 2 bits are made as 1 1, it would be like specifying as 8 bytes. If I
Okay.
made 1 0, so it depends upon the specifications. Like they would be
Okay.
like mentioning all the registers, like what and all bytes and bits it has been specified there. First part is like LCR register. It will just activate the DLR register. DLR is a
Okay.
device flash register.
Okay.
This register is mainly used for mainly used for storing the data, mainly used for the storing of the data. This data works on the baud rate of it. For example, baud is nothing but a clock generation of it. This DLR we would be like calculate since for example, one UART would be like one UART will be like working
Can
on
you
one
just
different.
stop there? And I have a question for you.
Yeah,
You so basically, as per my understanding, UART is universal asynchronous receiver
yeah,
transmitter.
yeah.
So it is asynchronous. So like, where does the clock actually comes into the picture here? Can you like explain why are you? Well, you said that you are using the clock. So what's the reason if
Yeah, yeah, yeah.
it is asynchronous? Why are you using the clock?
Yeah, yeah, yeah. Like for example, it is not easy for us to one device would be like operating in some other frequency, clock frequency. Another one
Okay.
will be like working on some other different frequency. For example, here 50 megahertz, there 100 megahertz means
Mhm.
this UART device would be uh, based upon a DLR value. DLR is a device slash value. based upon it, we'll be like calculating the clock. For example, one side of the for example, one for 50 megahertz, the clock would be like different. The waveform would be like different. Another device, it would be like operating in different clocks frequency. It would be like different. We need a
Okay.
proper synchronization between the one UART to another UART. Like the
Yeah.
proper synchronization should be achieved between from one data to another data. The device should be like accepting. So
Okay.
what we'll be like doing means we will be like calculating a value called DLR value. It
Mm.
is based upon a predefined formula. Like for example, system clock divided by 16 cross communication baud rate. So
Okay.
this baud rate is generally is used for synchronization purpose. Like
Okay.
uh, for example,
So
like one frequency, like if 50 megahertz would be like different from like 100 megahertz. We need a we need to sample and drive the data at a particular the same rate. The same rate.
okay.
It won't be like suppose we are like driving the signal in one end and one frequency, and another frequency will be like driving in different frequency. So it might be causing some desynchronization. So here
Okay.
we will be like using this baud rate. It would be like making it to drive and sample the same clock frequency. Yeah.
Okay. So yeah, so that means like we are just deriving another clock in order to synchronize our data transmission. Okay, so moving on to next topic. So are you comfortable with digital electronics?
Yeah, yeah, yeah.
Okay, so let's start with the basic question. What's the difference between digital electronics and analog electronics, and what is the requirement of digital electronics?
Yeah, yeah. Like analog is basically like the signals are like physical. Like for example, it is like continuous like signals. Digital is like we can just take the samples of it. Like for example, the continuous signal is not a discontinuous signals. We can take these samples and we can quantize. Basically, analog signals are very like it is too slow to process. From if you are feeding the analog signal into one kind of system, it would take some time to process the signal to get a desired output. But digital, on the other side, it is like easier for us comparatively. Analog signals are very difficult for us to transmit. Like it is not as fast as digital signals, and also like we can also use this how to say like analog electronics based upon this internally these flip flops and all based upon this. Even the logic gates are designed by using a this analog based upon the analog basics only. For example, uh, we would be like designing an AND gate using a CMOS and all these logic gates kind of things.
Mm. What is the requirement of digital electronics? Like why digital electronics? You said that the transmission is slow. Like analog is continuous in value and
Yeah, yeah,
continuous in time, right? So why is it
yeah.
slow? Like you're constantly getting data, right?
Yeah, constantly getting data, but for example, sometimes there noise would be like affecting.
Okay.
If noise affects the entire signal, would be like get corrupted.
Mhm.
For example, it is also too difficult for the system to just process the continuous signal
Okay.
for the specific time. Whereas in digital, we can discretize those samples into some kind of samples. So, for example, even one kind of bit is so for example, one sample got corrupted. We can easily discard that. We can just find the bugs easily there.
Okay. Okay. So what you would like to say is digital circuits are like more immune to noise and they are easy to sample as they are discrete in
Yeah, yeah,
value and time, right?
yeah.
Yeah. So, okay. So do you know what is a multiplexer?
Yeah, multiplexer is basically used for this data selector. Like
Okay.
based upon the select lines, we like selecting the data. For example, we can just take this music system. Like based upon, for example, like there will be like several, even the remote would be like a mux. I just from my point of, by my perspective, I'm like thinking like uh, remote, like for example, we can select the channels based upon our requirement. Like for example, based upon select signals, like we'll be like selecting the data. No? So yeah,
Okay. Okay. So what is the formula for the input to the select lines of the mux?
input to the select line of the mux.
Yeah.
Okay, 2 per n cross 1 into cross 1.
Okay. So to the power n cross 1, is it the formula for select line or the input of the mux?
You are asking this like it is a formula for the entire marks where n represents the select line.
Okay. And what is 2 raised to n into 1? So 2
It is a
raised to n, what?
mux.
No, no, no. What is just 2 raised to n? Why are you saying 2 raised to n? Is it like
Uh,
input? Is it like the output?
yeah, it is an input. It is an input.
Okay.
One
Okay.
is an output.
So we can say like we have single output and 2 raised to power n puts with n select lines.
Yeah,
Okay.
based upon the
So
n select line.
yeah, yeah. So why is mux called a universal?
Yeah. Based upon this mux, we can just design like many logic gates. For example, we can design an AND gate, and
Okay.
also like several logic gates. It can be designed. Like even not even logic gates, you can just design using this mux. We can send several cell circuits.
Okay. So can you please share your screen and like design NOR gate using 2 cross 1 mux?
Okay, one second. You have just disabled my screen.
Okay, let me second. Just a second. Let me get that access to. Yeah, you can now share your screen.
Okay. Could you see my screen?
Yeah, I can see. So a NOR gate using 2 cross 1 mux.
Yeah. So basically, NOR gate. One second. One second. Sorry. This is the NOR gate.
Okay.
So this not also will be like designing using another mux.
Okay. So now can you just give any input combination of your choice? Any two input combination so that we could verify the functionality of your design?
Yeah, sure. So, so I'm giving 0, 0,
Yeah.
getting 1.
Okay. So let's give 0, 0.
So if I'm giving 0, means they would be like here they would be like toggling, no? Here. So B, for example, B as 0. So
Okay.
this would be like selecting. This one would be like selecting, and
Okay.
answer would be like 1.
Okay. So now can you do it for 0, 1? Your
0, 1. Okay.
yeah, your A is 0 and B is 1.
0, 1. Okay. 0, 1 means 0, 1 means like or it on a 0. So if B is written as 1, so 0 would be like
Okay. So you said we could also implement a lot of digital designs using Mux. So what are the other designs that we could implement other than the logic gates?
yeah, like for example, we can just like other than logic gates, we can also design using this like we can design uh, a decoder logic also,
Okay. So can
and
you
also like
implement a D
and
flip
also
flop using 2 cross 1 marks?
2 cross 1 marks. Okay,
Yeah, D flip flop.
okay,
Yeah, you can erase this and you can start on
okay,
operation. So you could just select all and then you can just delete.
okay. D flip flop, na?
Yeah.
Okay. So obviously, like flip flop can be like designed using two latches, one positive and negative.
Mhm.
So like using a master slave configuration, we can just make. So
Okay.
first, I would be like designing this. Yeah.
Okay, can you explain me the working? Which is your positive level latch and which is your negative level latch?
Okay. Like this is like yeah. Like
And
this
also,
is
would you just like to recheck your circuit once again before explaining?
yeah. One second. Let it go. Like getting
Whichever is your positive level latch, right? Just put a plus sign there, and on the other latch, which is your negative, just put a minus sign. So I could get a better clarity.
yeah. So this is plus minus, I guess.
Okay. So now can you
So
explain the working?
yeah. Like for this latch, like for this negative thing, like this would be like passing, like D would be like passing. If the latch is like if the level is like high, it would be like returning the same state. So similarly at this point, like if it is like if it is a latch, if the level is like high, it would be like transforming the data into this output. If it is
Okay.
low, means it would be like still it will be like retaining its past statement, past state.
Okay. So according to your diagram, would you like to like check your waveform and the diagram of your second latch?
One thing, that's like that.
Because what I feel like your second latch. No. It's right. What I feel like your
Okay.
second latch, right? Using Mux.
Yeah.
So you are giving the feedback and the output of previous flip-flop on the same pin. So like how, so like when you give logic 1 to that mux, right? So don't
Yeah,
you think this will like just corrupt the value because you are like giving the data from the previous latch as well as you're providing the feedback. So don't you think that the feedback should be connected on the zeroth port of the mux or positive level latch?
yeah, yeah, yeah. Yeah, correct.
Yeah,
I just
yeah,
one second.
yeah. Because if it is positive level, so like, yeah.
Yeah,
Mm, okay, still not right. You need to make a little change. If your the second latch, right, the right one is a positive level latch, right? So it will latch
yeah,
the data when we get positive level, right? And if
yeah,
it
yeah, yeah.
is, if we are getting negative level, then we are just restoring the, yeah, just change it to zero and one.
Even here I should change, I guess.
Yeah,
Right.
there also then
Yeah.
you need to change
1 0.
one.
Yeah.
Yeah, yeah. So now it's correct. So, okay, so moving on to the next question. What's the difference between combinational circuit and sequential circuit?
Yeah, like combinational circuit is mainly depends upon the combinations of the act upon the combinations of the input. It doesn't have a memory. Whereas in sequential circuit, it depends upon the input and also the previous state of the output.
Okay,
Sometimes like it requires it depends upon the memory. Here the example of mux is like example in combinational circuit is mux and mux and decoder and comparator and adders. Like whereas
yeah.
there we would like designing a counters and also flip flops and also latches,
Mhm.
resistors and all these things. Here at combinational circuit, combinational circuit is like it's kind of faster since doesn't depends upon the clock signal, but whereas in sequential circuit it depends upon the clock signals.
Okay, so do you know the difference between latch and flip-flop?
Yeah, latch is basically a level sensitive device, whereas flip flop is a edge sensitive device.
Okay,
Latches can be used to just construct this flip flop, like using a flip latches can be used to construct a flip flop. And also since the clock signal is not present inside it since it doesn't depends upon the clock signal, it's like quite faster than flip flop. Like flip flop, since it depends upon the clock signal, it takes some time to process the data.
okay, so then why do we use flip-flop if why, what is the main reason like we go for
Yeah,
flip-flop and
yeah.
not for
Flip
latches?
flops this latch is a one bit like it is a one
Flip-flop
bit
are also
storage,
one
right?
bit, right? Flip-flop are also one
Yeah,
bit story.
depend for example, mainly it's like edge sensitive device. Depends upon the
So
edge of the.
what happens when we, what is the main reason why we are going from level sensitive to edge trigger? What is the reason?
Yeah, like edge sensitive, level sensitive in the sense why we are like going
Yeah, why we are,
from left.
yeah.
Yeah, from because uh, like uh, level sensitive in the sense it depends upon the specific level of the signal,
Mhm.
like depends upon the level, and also
Okay.
it is
But no, I get it. What is level sensitive and it's sensitive. But why, what is the main reason why in flip-flop we are moving to edge triggered? Flip-flop can could also be a level triggered, right? If you think of it as that way. What's the main reason? Like there is a one
mainly to
particular
eliminate the race around condition also, I guess.
that is the master slave configuration, but I'm talking about the edge trigger. So the answer would be to eliminate noise, right?
To eliminate the noise, like also yeah,
Yeah,
to eliminate the glitches present, like yeah.
yeah. So latches are more prone to glitches. Okay. So
Yeah,
latches
yeah.
do not have clock. Then why are they called as sequential circuits?
Latches are like though it is not having a clock, since it also depends upon the memory, like depends upon the past state of the memory. On
Okay, so because of the feedback, right?
yeah,
Okay. So moving on to next question. Could you uh, draw write a code for sequence detector of Verilog code? Okay, so we are moving on
okay,
to Verilog. So could you write a, Verilog code for sequence detector of 110101?
1 1. Okay,
Yeah, Verilog code. So yeah,
1 1 0. First, I have to draw the state diagram. No? Like I can directly just write.
yeah. Take your time. Take your time.
Okay. Like, can I use my note for drawing this FSM?
Sure, you can do that.
Okay, thanks.
Yeah, 1101. Okay.
1 1 0 1 1 0 1.
Yeah, and I want you to do a more machine.
More emission. Okay.
Yeah,
Like, otherwise, can I just draw this? Yeah. Like, so, like, default, like, it is reset. So, input
okay.
is 0, should be in the same state, and it
Mhm.
will be 0. Like, once this sequence is got, like, say output will be changing to 1.
Yeah,
So, if the input is 1, like here, 1, once again,
yeah, you can draw these circles if you want first.
is 1, 0. If it is 0, it should go to the S not state.
Yeah, and also make sure it's overlapping. Okay, the sequence has
It's
to be over.
overlapping.
Yeah,
Okay,
the
okay.
sequence has to be overlapping.
1 1. Like, if the sequence as now, if the sequence is 1 1, it should go to the next state
Yeah,
where here, if we are getting 1, like for example,
yeah,
the next number, if we are getting 1,
yeah,
it should, since it is a overlapping,
yeah.
this one is not required for us, since this one would be like a one triple one is not a sequence, proper sequence. So we would be like considering this one one.
Yeah.
So it should stay on the same state. If we get 0, it should move on to the next state, like
Okay.
0 and S3. Like S3, here, like we are getting 1 1 0.
Yeah.
So if it is 0 means, like uh, if since it is a overlapping, uh, it won't be like, though it won't be like forming any of the sequence. Like so, this 0 is also not required, like for us. So it should go back to the first state.
Okay.
And if it is 1, like if it is 1,
Mhm.
1 0 1 1 1 0 1, so obviously it will get. So like 1 0 1 0 means this won't be going to the state 0, and if it is 1 means 2, like would be like going to the state. Yeah.
Okay. So also I just wanted to ask you, what's the difference between Mealy machine and a Moore machine?
Yeah. Mealy machine mainly depends upon the input and also the present state, whereas Mori won't be like depending upon only on the present state of the
So what
of the output.
what is dependent and not dependent, like the next state or
Yeah, like output depends upon the
okay, yeah,
output depends.
yeah. So which is more better, Mealy machine or Moore machine?
Like it depends. Like for example, mainly prone to like glitches, whereas Mori is not prone to glitches. Like since it is depends upon only the state of the circuit, it won't be like prone into
Yeah,
the glitches.
yeah.
And
So
also
what
like
is
it is mainly is like quite complex for us to design. Like and also
Mhm.
here like number of flip flops like no like more would be like since the number of flip flops are like more would be like quite complex for us to design. As mainly they would be like obviously like states would be like lesser, so it is like
Okay?
easier for us to design.
So we are doing a trade-off, right? Instead of area, we are like choosing not to have glitches in our design.
Yeah, should I just write the code for it below?
Yeah, you can start writing the code for it.
Okay.
Yeah,
Can I use my notepad?
yeah, you can use Notepad, you can use EDA Playground, you can use any of your favorite editors.
Yeah.
So you can use whatever you want. Just share your screen.
Okay. Like whether my screen is shared, like shared.
I can just see the print.
Paint. Okay.
Yeah, share your whole screen, not the particular app.
One second. Could you see now?
Yeah, I can see it now.